Hello, my name is Ben Sherman. I'm the Business and Career Coordinator at Germanna Community College. I would like to welcome you to our podcast series. Today we have our NCC ER certified instructor, Donald Thomas.
Hello, my name is Don Thomas, and welcome to the Education Detective podcast series. Well, you may ask, what is an education detective? Well, an education detective is someone who solves a technical mystery in his or her area of expertise. Mine happens to be in the construction discipline. Today we're going to discuss reading architect and engineering skills and why they are so important. Okay, well let's get started. This whole measuring thing began thousands of years ago. The great builders used defined measurements to build some of the greatest structures of the ancient world. This was no easy feat. Many of these projects, such as the Great Pyramids of Giza, took decades to build and required an enormous amount of labor. The great builders of the ancient world needed two key things to pull this off. First, they needed a portable means to share information about planned construction events, and second, they needed a uniform set of measurements that everyone could use and understand. The ancient builders developed portable construction documents such as this one. These documents are the forerunners of our modern-day construction prints. Our modern-day prints don't look as cool as these Egyptian ones, but they get the job done. The ancient builders used a length from the tip of their elbow to the end of their middle finger to create a standardized measurement. They called it the cubit. No, not that guy on the Valentine's Day box of candy, but a length that was standardized by a device called the Egyptian Royal Cubit Rule. Today we use portable documents to describe construction projects. Now, let's get down to business. Today we use the fractional rule for construction. The fractional rule is what the architect and engineering scales are based on. But first, let's talk about the fractional rule. The typical length of the basic rule is 12 inches or 1 foot. Each inch of this rule is broken down into 16ths. As you can see, each tick mark, also referred to as graduations, represent 1/16 of an inch. There are 15 graduations for each inch segment of the rule. Standard sizes in construction are 1/8, 1/4, 1/2, and 3/4. Now let's look at an architect scale. This is your typical architect scale. Architect scales are either open divided or fully divided. An open divided scale is one that the main units are numbered along the entire length of the scale, with its subdivided units at either end. With the fully divided scale, all main units and subdivided units are shown along the entire length of the scale. The architect scale is an open divided scale. My next image will better illustrate this. This image is of two subdivided ends of an architect scale. To get important information on a construction print, an architect scale reduces the size of an object to a ratio equal to 1 foot in length. In this image, an actual quarter-inch distance represents 1 foot on some construction prints. You turn your architect scale to the desired ratio that matches the drawing scale you are reading. When reading a construction print, locate the scale information. It is typically in the title block or near the related view. You should match the drawing scale to the correct one on the architect scale. On most architectural prints, the quarter-inch equals 1 foot scale is the most common one used. Now let's do a few measurements using the architect scale. Let's do a simple scale reading exercise. Note length A in this image. Also note that we are using the quarter-inch side of the scale. Length A starts on the number 8. Each graduation on the elongated portion of the scale represents 6 inches. Read from 0 to the left as 6 inches, 1 foot, 1 foot 6 inches, and so forth to 8 feet in length. The line ends on the 8th tick mark or graduation after 0 to the right. From 0, simply count the number of tick marks to the right. I count 8. You read length A as 8 feet, 8 inches. Now, let's try a different length with the same scale. Length B starts on the number 11. So you read it from 0 to the left as 6 inches, 1 foot, 1 foot 6 inches, and so forth to 11 feet in length. The line ends on the 3rd tick mark or graduation from 0 to the right. From 0, simply count the number of tick marks to the right. I count 3. You read length B as 11 feet, 3 inches. Remember to use the correct ratio that matches the drawing scale you are sizing. Now, let's discuss the engineering scale. The engineering scale is widely used for making site plans, maps, and for other large, various construction projects. It is also referred to as a decimal scale. The civil engineering scale is a fully divided scale because all main and subdivided units are shown along the entire length of the scale. Now let's talk a little bit about this divide. Each side of this scale is divided into 10, 20, 30, 40, 50, and 60 parts of an inch. Thus, the edge marked 10 simply means that 1 inch has been subdivided into 10 equal parts. Using the 50 edge means 1 inch has been subdivided into 50 equal parts. Each part would be 1/50th of an inch. The engineering scale uses 10 subdivided parts per main unit. In the 10 edge scale, from 0 to 1 are 10 parts, from 1 to 2 are 10 parts, and so forth. All of the scale parts for this rule are set up the same way. The civil engineer scale is not limited by what can be represented. The engineer using this scale designates any length desired. Note in this image, 1 inch can represent many different distances by using different scales. Now let's do a couple of scale reading exercises. We're going to use the 30 edge of the scale, meaning that there are 30 parts subdivided by 1 inch. Start counting 10, 20, 30, 40, 50, 60, and 70. This line is 70 units long with the 30 scale. If we were to say that 1 inch equals 30 miles, for example, this line would be considered 70 miles long if represented on a highway plan. Now using this same 30 edge scale, let's look at another line. From 0, let's count our units. 10, 20, 30, 40, 50, 60, 70, 80, 90, 100. The line ends halfway between 100 and 110, which is 105. Remember, there are 10 subparts between each main unit, so this would be the middle part. Now that we have reviewed reading architect and engineering scales, let's do a recap on what we have learned. I've put together a checklist. Let's go through that checklist and also look at some do's and don'ts of using architect and engineering scales. Key things to remember. Both the architect and engineering scales are based on the standard fractional rule. Number 2, the architect scale is a ratio of a fractional inch to an actual 1 foot length. Number 3, the architect scale is an open divided scale, meaning main units are numbered along the length of the scale and smaller subdivided measurements are opposite the 0 point. 4, architect scales are normally used for architectural prints. 5, the civil engineering scale is based on subdivided parts of 1 inch. Each scale represents the number of units measured in a 1 inch distance. 6, the civil engineering scale is also called a decimal scale, and each main unit is divided into 10 parts. These scales are used for site plans and maps. And 7, the engineering scale is a fully divided scale, meaning all main units and their subunits are found along the entire length of the scale. Now, here are some don'ts on using scales. 1, only scale an original construction print. Copies are distorted and would provide misleading measurements. 2, protect your scales from damage. Indentations on the scales will remove graduation marks. 3, don't use scale measurements you found yourself unless they are approved by the site manager. And 4, never write your scaled measurements on the original approved set of plans unless you are authorized. Ask for a markup copy to be written on. Have the site manager approve your scale before they are used on the job. Thanks for watching my podcast video presented by Germanna Community College. Your career dreams are our passion. Start your dream now and enroll in one of our training programs. Thanks, and see you next time on The Education Detective.
Thanks for viewing our podcast. Please visit us at www.germanna.edu/workforce and find out more about more of our apprenticeship, our commercial equipment repair, our electrical groundsman, and many other programs. Start climbing the ladder to success today at Germanna.